So I think this is recording. Let's take a look at four problems that are very similar. In our skill packet number 6, we are taking a look at complex numbers. And when they say operations on complex numbers, they simply mean addition, subtraction, multiplication, division. That's what they mean by operations in a math class. So the directions here are telling us to simplify the following radicals using the imaginary unit. The imaginary unit is I, and we define I to equal the square root of -1. So we're going to use this in every problem here. The first thing that I do in each problem is I split the radical into two radicals. I split it off. Then I've got the positive square root of 196 times the square root of -1. I do that for all of these problems. That's my first step each time. The 3 was out, it was not underneath the radical, so I just left it alone. And the square root of -18, I split it apart and took the square root of positive 18 times the square root of -1. And here, I'll take the square root of positive 120 times the square root of -1. That's going to be my first step anytime I have a negative radical. Again here, I'm going to take the square root of positive 80 times the square root of -1. All right, so let's go back to number 1. So I've established now that that's the first step I'm going to do in each type of these problems. Well, now, how am I going to simplify radicals? I would suggest that you play around with the calculator, or maybe that you try to memorize the first 20 numbers squared, that 17 squared is 289, that 13 squared is 169. It will help you to do this a little bit quicker, and of course you always have a calculator as a backup that you can check. The 196 is a perfect square. 14 times 14 is 196. So now I can simplify the square root of 196 as 14, and the square root of -1, look over here to the side, the square root of -1 is I. Sometimes if you don't have it memorized, some of these larger numbers that are perfect squares, you'll want to break it down as a product of prime numbers. But here I recognize that 14 times 14 was 196. All right, so let's take a look and continue this one. 18 is a little bit smaller of a number, so it should be easy for us to think about what the prime factorization of 18 is. I always refer to this as a factor tree. So 18, well, that's an even number, so that's 2 times 9. And then 9 is 3 times 3. And I'm sure you've seen that before. Now, you don't have to necessarily do it like this. Maybe you have some other system or way to break down this 18. But do develop and practice some system. Like I say, I always just write it right underneath there. Now, with square roots, I'm looking for a pair of values. See, we say that 9 is a perfect square because 3 times 3 is 9. When I have found a perfect pair, you pull one factor out from underneath this radical symbol. So the 3 on the outside is going to stay there. And then because I found a pair of 3's, I'm going to multiply it by another factor of 3. The 2, it stays underneath the radical. See how I've circled it in a different color? And then the square root of -1, that's going to be I. So the first factor of 3 just stayed there. The square root of 18 is equal to 3 times the square root of 2, because the largest perfect square that divides 18 was 9, and we can look at 9 as 3 times 3. The square root of -1 by definition was I. Now all I have to do is just 3 times 3 is 9, and I will very seldom ever write the I as the last factor here, because I wouldn't want anyone to not read my handwriting correctly, or even myself. If I accidentally extend this radical too far, where I think that I is underneath there, then I have really complicated that problem quite a bit. That's a much harder thing to simplify and talk about. In fact, we're not going to talk about the square root of I. So The 3 times 3 was 9. It's times a square root of 2 times I. Since I can write multiplication in any order, I will move that I in front of the radical so that there's no misinterpretation of what I'm trying to multiply. All right, so let's take a look at number 3. We already know the first step. Break it down to square root of positive value times the square root of negative 1. Square root of negative 1, by definition, that's going to be I. I need to break down 120. So I just solved the 12 and said, hey, 4 times 3 is 12, so 4 times 30 is 120. You can start anywhere. Maybe some people will just start with the fact that it's an even number and say 2 times 60. But when I saw it, I broke it down. There's usually a line there. I don't know why it didn't. That 4 times 30 was 120. Well, then I looked at 4, and hey, I broke 4 down to 2 times 2. Oh, there it is. Somehow it got moved. Then I broke down 30 as 2 times 15, and then I broke 15 down to 3 times 5. Well, see, I found a pair of values here. Here's a pair, 2. This factor of 2 didn't have another factor of 2 to make a pair. This 3 was just a single factor of 3. I couldn't make a pair. This 5 was a single. So I circled all of those. I boxed in my pair. When I have a pair and it's a square root, one of these factors comes out from underneath the radical. So I'm going to write a 2 in front of that radical, but all this 2 times 3 times 5, that stays underneath there. And you can look up above here. 2 times 3 times 5 was 30. So I'm going to have 2 times the square root of 30 times I. I don't like to write the I there. It's if you do write it there, just make sure that your handwriting is neat, that you've shown your work, and that I clearly understand that I is not underneath the radical. I would suggest that you write that factor of I in front of the square root and write your final answer as 2 times I times the square root of 30. All right, so let's look at the last problem we're going to make in this video. We're simplifying the square root of negative 80, and we first just split it apart and said the square root of negative 80 is the square root of positive 80 times the square root of negative 1. I know that second factor, that square root of negative 1 underneath this in my next step is going to be I. What I'd like to do now is break down this 80. You've got different ways that you can break it down, 2 times 40, 4 times 20. What I saw when I broke it down was 5 times 16. So I wrote it down. 5 times 16 times 5, 5 times 16. Circled the 5 because it's a prime number. I'm not going to be able to break that down any further. 16 is 4 times 4, and I found a pair. That's what I'm looking for when I take a square root. If I have a pair, then one of these factors, I always jokingly say that it escapes the radical, that it goes outside of this radical. So I'm going to write a 4 out in front of a radical, and then underneath the radical, since this has now been simplified, what's left is that prime number 5, and then times I. And of course, I would suggest that you not write that I as the final factor there. So I'm going to write my final answer as 4 times I times the square root of 5. So hey, I hope this helps, and I'll talk to you later. Well, was it even recording? It was not. That sucks. All that work. And I wasn't even